In this video, I'm going to solve this Euler's equation with condition that x is positive, meaning x is greater than 0, x square y double prime minus 3x y prime plus 4y is equal to 0. To solve Euler's equation, we make the following assumption. We assume that our solution is of this format. Y of x is equal to x to the power r. Then we are going to go ahead and take the first and second derivative. So first derivative is r x to the power r minus 1, and the second derivative is y double prime of x is r times r minus 1 times x to the power r minus 2. Now I'm going to take these values y prime and y double prime and plug it into this equation. Once I plug it in, I get the following. I get this. It's pretty straightforward algebra. Once you do it, you'll get it. So this obviously is not equal to 0. So it must be the case this is equal to 0. This is a quadratic equation in R. We can solve it. I just factored it here and got the solutions, got the roots. So both of the roots are the same. R is equal to 2 and R is equal to 2. So one of the solutions, or y1 of x, is gonna be x to the power 2 or x squared. However, what is the second solution? Since the roots repeat. Second solution is slightly different. What we do, we make, let's use just y of x. So the second solution, which we will call later on y2, so is gonna be x squared times some other function of x, okay? So we are making the assumption that y2, or the second solution, is going to be just x squared, the first solution, times some function of x. Now what you can do, you can take the first and second derivative of this and plug it into the original equation and then try to solve it. Once you solve it, there is a lengthy process which I'm not going to go through. Then you're going to get u of x as something like this, c1 plus c2 ln of absolute value of x. Now that's going to give you your y of x, which is here, equal to x squared times c1 plus c2 ln of absolute value of x. Now if I simplify it a little further, I get y of x is equal to c1 x squared plus c2 x squared times ln of absolute value of x. Now c1 and c2, by the way, are arbitrary constants, right? By looking at this, we can figure out our second solution. Since our first solution is x squared, right, which you already found, y1 of x, so you have x squared here. So your second solution, y sub 2, is going to be x squared ln of absolute value of x. Now your general solution is going to be linear combination of this y1 and y2, some arbitrary linear combination. So it's going to be of this format. Y of x is equal to c1, again some arbitrary constant, y1 plus c2 y2, which is going to give you y of x is equal to c1 times x squared, right, plus c2 times x squared times ln of absolute value of x. I kind of use the c1 and c2 couple of times here, here and here. It's kind of like important to keep in mind that we are a little bit loose about it because these are some arbitrary constants. I use the same symbol for it. Anyway, I hope that this discussion was helpful. Thank you very much.